Hey guys, today we're going to be talking more about domain and range, and we're going to learn two new vocabulary words, discrete and continuous, which is just a different way that the data is presented and what that means depending on how it is represented. And again, like domain and range, and we just don't want to get the two mixed up because in and of themselves it's pretty easy information, but we don't want to get it mixed up. So let's move right along here. Just to begin, a reminder that the domain is a set of X values. So again, we want to remember domain. It's going from left to right, the least to the greatest. The range is a set of Y values. And again, it's this way. Now, the least is down here, and then it gets greater as it goes up. So keep that in mind because it's interesting that sometimes students will flip that around. I'll flip it around if I'm not careful. So it says a function and non-functions, they can either be discrete or continuous. And a discrete function is one where the points are not directly connected, kind of like points on a graph. It says, so you would have to lift up your pen to go from one point to another point. As soon as you're lifting up your pen, it's going to be considered discrete. The following are all typically discrete. So keep this list in mind. You'll probably have a test question on it. Ordered pairs, function maps. If you remember the function maps we did 2 days ago with the two circles, the X's in one, the Y's in the other, and we drew lines across. Tables, like a table that have a column of X and a column of Y. Those are typically discrete unless it's associated with an equation. Graphs where the points are not connected, and then real life scenarios. For example, buying a box of cereal. I can't go to the store and buy 1.3 boxes of cereal. So it's one box, 2 boxes, 3 boxes. Okay, so we're going to look at different ways you might see a function represented on a graph or a table. But now we're going to say, okay, this function, is it a function? First, we'll ask that question, and then we'll say, is it discrete or is it continuous? So on the first one, it gives us a bunch of ordered pairs, and we did something like this. And to save time, I went ahead and graphed them. And then it says graph the points to the right, and then they ask, is it a function? Now you could look at the ordered pairs or you could look at the graph, and you would say, no, they're not. And you can see that the X, whoops, not that one. The X value is repeated. You can see this graph with the dots on it, ordered pairs graphed under that, it would fail the vertical line test. Is it discrete or continuous? And you would say discrete, and then domain. Now again, we're going to write the domain in brackets because they're discrete, we're going to list them. We already did this in one of the other lessons. I'm going to create my bracket, and I'm just going to look at all the X values. And I have to be kind of careful because I want to go in order. I'm not going to list anything twice, and I'll try not to screw this up. Easy to do. So let's see, -2, -1, 0. Okay, it looks like I covered it all. If I messed up, I'm sure you'll tell me. And then the range is all my Y values. I want to start from the least and go to the greatest. So I see that I have a -6. That's probably the least. -2, -6, -2, 3, 4, 6. 3, 4, 6. And you can see I have more ranges and domains because the domains, some of those repeated. Let's look at the next one. Is this a function or is it not a function? We can see that no, it is not a function. And it is, this again would be considered discrete. Now I'm not going to list the domain and range to save time, but you should. I did this one, I did the first one, you do the second one. Make sure to put the brackets, make sure to put them in order. So go ahead and pause the video right now and take care of that. Page 2, a continuous, continuous. I think I spelled it right. Function is one that is connected, which means it includes all the values in between given points. You can easily trace the graph without picking up your pencil as you go from one end to the other. And then they give you some examples right there. Equations, graphs, if connected, tables, if they're connected to an equation or graph that is connected. Real life scenarios where all points are involved. And again, we'll just talk about this. I'll give you some examples. Now, there are two different ways to write these in notation form. We're going to be using inequalities, and some of them will have ends, like the least and the greatest, and some of them will be continuous. And it's really important that you don't get these two mixed up or confused, because this is where it gets kind of, you have to really start thinking about what you're doing on this one. So if you look right here for domain, you can see this. This means that there's endpoints. The least as x can be is a -12, and the most it can be is a +6. And then this is continuous. It's just going to keep on going. It has one endpoint, but then it's going to keep on going the other way. And then the range, and I want you to notice that for domain, they used x here and x here. For range, we have a y here and a y here. So you want to keep that straight in your head too. It's not always going to be x. Sometimes it's going to be y. And the y means range. The x means domain. So keep all those things in mind. So if I look at this next one, use the graph to the right to answer the following. Is it discrete or continuous? You know, it has two endpoints, but in between everything's connected. So we're going to call it continuous. Sometimes people think it has to go on and on and on and on forever to be continuous. No. If you have two dots and they're connected by a line, that's continuous. That's all you need to be continuous. Is it a function? Yes, it passes the vertical line test. So yes. The domain. Okay. So here's where we need to be thinking. Okay. Domain is x. Range is y. So the least that the x's are, if I look at this graph, is, again, here it's all of this from here to here. So the least, watch this, I'm talking about domain. So I'm going to put an x right there in the middle. The least value is 0. The greatest value is 5. There's dots, solid dots, so it includes the 0 and the 5. So x is greater or equal to that 0, but it's less than or equal to the 5. And so that's how I wrote that one. Let's look at the range. The range is the y. And here again, you have to be super careful because we need the least value on the left and the greatest value on the right. So if you look, here is the range. The range starts at 0, and it includes 0, and it ends at 50, but it includes 50 because of the solid line or solid dot. So it's less than equal to 0, and greater than equal to 0, or it is less than equal to 50. So 0 is less than equal to y, which is less than equal to 50. So again, there's ends. Let's look at the next one. Discrete or continuous? It's continuous. Is it a function? Yes, because as x changes, y is going to change. And so we'd have to work this one out. We would have to say, well, actually on this one, it's going to be all real numbers, because whatever x is going to be, then y would be. And we could put any number we wanted in for x, and we would get in the y. So both of these are going to end up being all real numbers. Ugh. Okay, so it just keeps going and going and going and going. If I drew this on a graph, it would be a line with arrows on it. It just keeps going and going. Okay, let's look at the next one. Is this discrete or continuous? It's continuous because even though there's endpoints, they're connected. So we call it continuous. Is it a function? Well, let's see. Vertical line test? No, it fails it. All right. Watch what we're going to do with the domain and range. So let's see. The domain is X. So I'm going to put an X in the middle. And I'm going to look at, let's see, here's the least value, -5. And the greatest value is over here. Don't look at the two dots because this kind of curves around. So I'm actually going to look over here at the -1. So we have a -5. We have a -1. And then I want you, there's a solid dot on right here, solid dot. And if it's a line that crosses over, it's kind of like a solid dot. So I can put less than equal to, and I'm done. So again, these are the ones that you have to really be thinking. Last is range, which is my y. And so I can tell that it's going to have ends. So I'm going to look for the least. The least is right here at the 1. The greatest is up here at the 5. So we have less than equal to, less than equal to. And so y is greater than or equal to 1, but less than equal to 5. Or I can read it from left to right and say y is less than equal to y, which is less than equal to 5. And that is it. Good luck. Be careful on when you're writing out the domain and ranges. All right. I'll see you later. Bye-bye.